We've already kind of did this on the transformations. If you remember on the transformations ones, you had the coordinates. Like A was 3, 2, and B was 1, 5, C. And if you dilate it, remember a dilation means you shrink or expand proportionally. All you got to do to find the new points is take each point times scale factor. Remember doing that before?
No. Yeah.
So 5 halves times 3 is 7.5. 5 halves times 2 is 5. 5 halves times 1 is 5 halves or 2.5. 5 halves times that is 25 halves, 12.5. That'd be 0, 15. Okay? Everyone kind of remember that? So the scale factor, this was one of the questions on the test. How can you tell if it gets bigger? More than 1, and if it gets smaller, it's between 0 and 1. So now here we've got the drawings. I don't think I showed you this before. To dilate this scale factor of 5 halves, what you got to do on this is you got to measure every length. Oops. I forgot to put through X. So AX, BX, and CX. You got to measure all those. So I'll just do it in centimeters. So there we got 33, 22, and 23. So then what you do, just like we did with the coordinates before, you take all of these times the scale factor, 5 halves, and you have new points, AX prime, BX prime, CX prime. So 5 halves, you know, is 2.5. It's quicker to do it that way. So this is 82.5, 55, and 57.5. So what you do is measure again from A to X, but I measure out 82.5. So there's my new A. And then B to X, I measure out 55. So there's my new B. And C to X, I measure out 57.5. There's my new C. And I should have connected these. Okay. Yeah.
Wouldn't you measure it from X to the new point, or?
Oh, you're right. I measured. No, it's from X. I measured it the wrong way. You're right. It's supposed to go this way. So now I got. Well, I'll just draw right over. So from X to A, it's 82.5. So I just measured the wrong way. It's got to go out this way. And then from B to X, 55. And from C to X is 57.5. So you may have done this, you guys have had art class? If I connect these, where I measured, do you know what kind of a drawing that's called?
Enlargement.
It is an enlargement. This is 2.5 or 5/2 times bigger. Did you do this in art class? Anyone remember?
No, she didn't do it. It's just-
PLTW?
Yeah.
Yep, this is the point of origin. If you had a drawing, well, I can't draw that very well. It's called the point of perspective. You guys remember that? No? Point of perspective, it's like if you see a picture of a city, it starts off wide, like if you're looking down a road, it narrows to a single point, because closer to you is wider. Okay?
We did that when we were doing the tree
You did it when?
house. We were doing a tree house.
So that's perspective drawings, is you do that. So anyway, that's what we're doing. Now this works both ways. Remember, you can find the scale factor of any two figures. We've been doing that. It doesn't have to be just triangles, but say this is 15 and this piece is 6. You can use this to find the scale factor. It's 15 to 6, which reduces to 5 to 2. Okay? You don't need to use just pieces of the triangle, though. You can use the distances. Like if this piece here, I gotta think of something. Well, I'll just use this. If this is 6 and this is 9 from here to here, erase all this other stuff. Same thing, the distance from here to here, from the point of perspective to there is 15. The distance from here to here is 6. So that's really all that's new, is that you can use the lengths they are from thing. You don't have to use just the pieces of the triangle.
So then if you wanted to go from big to small, you would just flip.
Yes. So that is if we're going from small to big, or if it's an enlargement, it's 5/2. But say it goes backwards and it's a reduction, then you flip it. It's 2/5. Remember we did that before too? If it shrinks, it's less than 1. If it's bigger, it's more than 1. So, that's really all this is. They don't really have this labeled great. They have a P here and a P prime here. So there's one triangle. Here's the other. So, you know this is the original. So it's getting smaller. So when they say identified, that means, say, is it enlarged or reduced? So you'd say reduce. And then the scale factor, we don't know any of the sides, but we know this is 5 away and that's 3 away. It's either 5/3 or it's 3/5. Which one is it?
3/5.
Since it's reduced, it's got to be the one that's less than 1. Here's the P, here's the P prime. So this one is getting bigger, so it's enlarged. And then again, it's either 5/12 or 12/5. It's 12/5 because it's getting bigger. That's what this whole section is. So it's pretty easy. Okay, we don't have to go through the drawings of it. I just wanted to show you that's what it is. Okay, so here, this is the image because it has the prime marks. This is the original. So it is reduced. And then the scale factor. You don't have to use the sides. You can use any corresponding piece, which what I would use, because it's easy to count, would be this diagonal and that diagonal. This is 1, 2, 3, 4. And this one is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's 4/10 or 10/4. Since it's reduced, it would be 4/10. You don't need to simplify the scale factor, but you can. That'd be 2/5. Either one is correct. That's it. That's all we're doing is the enlargement, reduction, and then giving the scale factor.
No, it's.
The best list there.